In this video, we will learn about insertion sort. So, how does insertion sort works? First, we will assume, suppose this is your array A and these are the elements in the array, that is 22, 86, 14 and 51. So we assume that the first element is already sorted and we don't need to sort the array. So the entire array is broken down into two parts, that is sorted part and the unsorted part. So from the unsorted part, that is from this part of the array, first we will choose one element and compare it with the elements of the sorted part of the array. So 80 is compared with 22. So we can see that 22 is smaller than 80. So we do not need to shift 80 over here. So after the first pass of the insertion sort, the elements of the sorted array are 22 and 80, and in the unsorted part of the array we have 6, 14 and 51. So now in the after this was your first pass. Now in the second pass we take the first element of the unsorted array, that unsorted part of the array. This is your unsorted part of the array. So we compare 6 with 80 first. Which one is smaller? So 6 is smaller than 80. So what we have to do? We will place 80 in the position 2 of the array. So what will happen? Here 80 will come. Okay. Now we will compare 6 with, first it was compared with 80. Now we will compare 6 with 22 and see whether 6 is smaller than the 22. Yes, it is smaller. So we will shift 22 one place to the right side. That is, its place was 0. It will be shifted to 1. So it will come at the first index. And your 6 will be placed at this empty location. So this is your sorted part of the array 0, 1, 2, and the unsorted part of the array contains 14 and 51 after your second pass. So now for the third pass we will take 14 as the element of the unsorted array, alright, and we will compare this 14 with the elements of the sorted array. First we will compare 14 with 80. So if 14 is smaller, then we will shift 80 one place to the right side, that is to this side, one place. So 80 will come at the third location, and then we will compare 14 with 22. So 14 is smaller than 22. So 22 will be shifted one place to the right side. So 22 will come at the second index. And now 14 is compared with 6. So 14 is not smaller than 6. So 6 will remain at its own place. There will be no shifting of 6. So at this vacant place, we will bring 14 here. So this is your sorted part of the array now with index 0, 1, 2 and 3. So this is your sorted array and 51 is your unsorted array at the index 4. Now again same thing we will repeat for the fourth pass. So 51 we will take the unsorted 51 element we are going to take from the unsorted part of the array and compare it with the sorted part, that is with 80. We are going to compare. Is 51 smaller than 80? Yes. If it is smaller, shift one place to the right. So 80 will shift one place to the right. Now we will compare 51 with 22. Is 51 smaller than 22? No, 51 is not smaller than 22. So 22 will not shift one place to the right. it will remain at its place, that is at index 2. So 22 will remain as it is here. Further, we are not going to compare with the other elements. Why? Because it is already sorted. If something is not smaller than 22, then it will also be not smaller than 14 and 6. So these elements will remain at its place. And we can see this is our array. Now this vacant place is filled with 51. So now you have, after the fourth pass, these are the elements of the array in the insertion sort. So after the fourth pass, we can see the array elements are sorted. So we have seen that there is no swapping done, only shifting was done here in this array. This is the algorithm for insertion sort, a small code snippet. So here we can see that the variable I is used, the variable n is used. So I is used to traverse the array and n is the number of elements present in the array. So for this example, n is equal to 5, and temp is a temporary variable that is taken to store the value of ai. So what is AI? Earlier we have seen this 6 value or this 14 value or this 51 value, and in every pass is stored in some temporary location first. So this is temp used to store the value. Alright. Now J is another variable used to traverse the index of the array. So we can say that I is a variable, temp is another variable that is taken over here, and this is J. So we start with I is equal to 1 and temp. What is I is less than 5? Yes, the condition is true. So we enter the for loop. Temp is equal to A of I. What is A of I? I value is 1. What is A of 1? A of 1 is your 80. So 80 is stored in the temp variable. J is equal to I minus 1. So J value is I minus 1. That is 1 minus 1. J is your 0. So now while loop, J is greater than equal to 0. Yes, the condition is true, and A of J, that is A of 0, is A of 0 greater than temp? Temp value is 80. A of 0 is 22. No, it is not greater than. So condition is false. We will come out of the while loop and we will come to this statement. A of j plus 1. What is j? 0. So A of 1 is equal to temp. Temp is your 80. So now A of 1 is temp. So this is your first pass. After the working of the first pass, we are going to return to I plus plus. So I becomes 2 now. We will check again the condition, 2 is less than n or not. So yes, 2 is your less than 5, right? So temp is equal to A of 2. A of 2. What is A of 2? A of 2 is your 6. So now temp contains value 6. So j is equal to I minus 1. What is I? 2. So j becomes 2 minus 1, that is your 1. So while j is greater than equal to 0, yes, 1 is greater than your 0. A of j is greater than temp. So A of j, that is A of 1, is it greater than temp? A of 1 is your 80. Is 80 greater than 6? Yes, it is true. So we will enter the body of the while loop. A of j plus 1. J is your 1. So A of 2 is equal to A of j. What is A of j? A of 1. So what will happen? A of 2 will be store the value of A of 1. So now j is equal to j minus 1. 1 minus 1, j value becomes 0. Now we are going to come to the next. Out of the, we will enter the while loop. Again we will check the condition. Is j greater than equal to 0? Yes. Then we check aj is greater than temp. What is aj? A0. Is it greater than temp? That is 6. A0 is your 22. 22 is your greater than 6. The condition is true. So we will again enter the while loop. In the while loop, what we have? aj plus 1. aj plus 1. So a of 1 is equal to a of j, that is 0. So what is a of 0? 22. We assign it at, so 22 is assigned to a of 1. So 22 is assigned over here. So now j is equal to j minus 1. So j value becomes minus 1. Now we go to again check the while loop condition. J value is minus 1. Is minus 1 greater than equal to 0? No. The condition is false. We come out of the while loop up to here. Now what is here? A j plus 1, that is minus 1 plus 1 is equal to temp. Temp is your 6. So a of 0 is your 6. So 6 comes over here. So we have seen how this algorithm is working. Okay. So this, first we checked the 6 with value 80. Then we checked it with 22. It was greater, so we shifted this 80 here, shifted this 22 here, and then in the end we shifted this 6 at this position. So this is how your insertion sort algorithm works. So you can do it up till the end of the algorithm. You will increase again the value of I for the third pass, and it will continue as we have seen in the first slide of this algorithm, insertion sort. So this is all about insertion sort.